Welcome back to Educator.com. We have another lesson today in Intermediate C++. Today we are going to do the first half of object-oriented programming. Okay, one of the strengths in C++ over its predecessor C is the ability to implement object-oriented programming, typically called OOP. You'll also hear OOD sometimes as object-oriented design, or OOA, object-oriented analysis. You have to do analysis and design before you do the programming usually, but that's okay. We're not going to talk about too much of that. So the data and the structures are gathered into an object. It's different from earlier ways of looking at things is how you organize your data. So you will have an object that contains all your data and functions that operate on those data, and they're defined in classes, and they're isolated away from other objects. You have objects that are responsible for certain functions, have other objects that are responsible for doing other things. So the object-oriented programming emphasizes these important concepts. Now, earlier than that, you had to do things like this anyway to have a strong, easily maintained program. But object-oriented programming emphasizes it more, which we have data abstraction, encapsulation. Inheritance is completely new. Is done in object-oriented programming. You don't see that in functional programming at all, or procedural programming, excuse me. And of course polymorphism, which is also important, but you do see a little bit of that in earlier programming styles. But object-oriented programming explicitly defines ways you can have polymorphic behavior. Now your objects have different types of relationships. In particular, they have an is-a relationship, where an object is some other object, such as a horse is a animal, or a car is a vehicle, that sort of thing. And then you have has a relationship, where a car has a tire, a car has a front seat for the passengers, a horse has a tail, etc., etc. Now, one of the things C++ has that other object-oriented languages don't have, it has multiple inheritance. So an object class can inherit from more than one class, and this thing wrapped weird. This should be a plus here, should say C++, and that plus shouldn't be there. But we won't worry about that today. So an object can inherit. You have an object which is this, is also is that, and so if there's attributes, if there's functions and data that can be used in that parent or superclass, then you use that one. If it's something that's in this other one that's useful, then you use that one. Have as many of them as you need. So you can inherit more than one class. We're going to talk about construction today. A class object has to be constructed when you initialize a new one. There's also a destruction, but we'll talk about that in the next lesson. So we have construction, which allocates the memory that will hold the object instance, and it should be controlled by the programmer. If you don't provide a constructor, the compiler will give you one, because you need to have a way of constructing a new object. Now, the default constructor that the compiler gives you may not be what you need, so it's always a good idea. It's a good practice to make one, even if it doesn't do anything. Just put one there so you can add things to it later if you need to. Now, there's a deep copy versus shallow copy, which we'll talk about. If you need deep copy, you have to provide a copy constructor. So when you copy an object, this object into this other object, there's all the parts and members and pieces of it that have to be copied also. And the compiler does a shallow copy if you don't provide it a copy constructor. Sometimes you need a deep copy. Now, we will talk about that later in this class. Okay, historically, we've had some distinct ways of programming design. There's the procedural, where you have an algorithm, we do this step, and then we do this step, followed by this step. We make a test. If the test is true or false, then we'll wrap around, we'll go back and do this test again. Now, That's been pretty much, you're still pretty much doing procedural programming, no matter what you're doing, except for some strange types of languages we're not going to talk about at all. Some years ago, structured programming was defined. So instead of having a go to here, we'll go to back to there, and we have a go to in here, which goes down to there, which cause all sorts of spaghetti coding problems where your code would go up and down and left and right, and it was very difficult trying to fix that when there was a bug in it or for someone to understand it. So structured programming introduced the concept of putting everything inside of a code block where you do not jump out of it and you do not jump into it. So you have a if statement that says, instead of an if test where you jump around it, you have a block, and an if test at the beginning of it. If it's true, we will handle this block. We'll have this block this block of code needs to be executed some number of times, so we'll loop around in this block of code. Now, object-oriented, on top of having these blocks and structured programming, you also conglomerate all of your data and methods inside an object. All of the data here is associated with this thing.